You know all those times you've wondered how they come up with chemical formulas, like all these chemical formulas we have and we can do in nomenclature? How do they ever figure that out in the first place? Maybe you've never wondered that at all, but it's probably an important question for chemistry, or in chemistry, or for a chemist to be able to answer. So we're going to talk about that. So a few bits of important background. Number one is we already know how to do, or we should already know how to do, percent composition by mass. And what that gives us is how the masses of each thing are related to each other. But it's a ratio of masses. But what we really want in our formulas is a ratio of numbers. Not masses, but numbers of atoms. So our first step is going to be coming up with the simplest formula. And the simplest formula is just a mathematical relationship between them. And then what we're going to do is we're going to come up with the actual formula where it tells us what the thing is. So if you think about fractions, where you have fractions in the simplest terms, that's kind of what the simplest formula is. And then what we need to do is have the actual chemical formula, which is in some cases I don't want to say like an unreduced fraction, because I don't really want to think about this in terms of fractions, but where you have the actual ratio of atoms, even if it could be mathematically reduced. So we're not going to be mathematically reducing things. Okay, how are the two things related? Well, if I take a molecular formula, and I have a few of them here, all of these things are actual chemical formulas of real compounds that we might know about. But if you were to look at the lowest ratio of atoms in these things, some of them can be reduced. Not all of them, some of them. So we need to have a tool that allows us to figure out, is this thing the actual formula? And if it's not the actual formula, if it's just the lowest ratio, how do we get from that lowest ratio to the actual ratio? So that's kind of what we're going to be spending our time with. So we're going to start with the simplest formula, which you'll sometimes see, I think your textbook calls this the empirical formula. I don't use that, I call it the simplest formula. What we're going to do is we're going to start with that percent composition by mass. That's really the only thing we know, how the masses are related. And once we have the masses, then we are going to turn those into numbers of moles. Okay, now numbers of moles is going to relate us to, or going to allow us to relate to numbers of atoms, because it's effectively the same number. But the problem is the masses that we have won't necessarily be whole numbers of moles. So we do this step 3, where we divide each one by the smallest number of moles, which feels kind of weird at first, but what that does is it gets us to whole number ratios in most cases. If we don't get whole number ratios out of that, then what we do is we have to do some modification for it. Now, we'll do an example or two, and I will say you will always do step 1, 2, 3. We won't necessarily always do step 4. It's if necessary. And when I say not easily roundable, the obvious question is how much rounding can we do? And the answer is all these chemical formulas will come out to whole number ratios. These things, chemical formulas are always, almost always, in our cases, always related by whole number ratios. So if we are far away, there's either been a mistake or we need to do step 4. Okay. Try this one. So I would encourage you to actually write this down, follow along, work the examples as we go through them. Okay, the question is going to be like this. You're going to be given percent composition by mass numbers and then asked to come up with the simplest formula. So the first thing you do is you take those percentages as masses. So if I had 100 grams, then I would have those numbers of grams of each thing. Then I'm going to divide each one by the molar mass of that atom or of that element and turn that into numbers of moles. Now you notice the numbers of moles are kind of all over the place, and that's okay. The smallest number of moles is shared by nitrogen and oxygen. So I'm going to divide everything by that. And what that's going to do is it's going to divide everything by that small number of moles. It will automatically turn, in this case, 2 of those things into a whole number of 1. Everything else gets turned into a whole number or far enough away that I cannot round it. And forget about the rounding rules that you had in math. These will work out really, really close, like 0.99 or something 0.5. If you get the 0.5, okay, well I cannot round that up, so I'm going to multiply everything by 2 in order to get whole number ratio, and then my simplest formula is those numbers attached to the element that I was using them for, or getting them from. So that's pretty much it. Pretty simple, straightforward. The simplified table, the sort of what I would expect from you if you were doing this question is there. So the masses, what you get after you come up with the numbers of moles, what you get after you divide by the smalls. You don't have to tell me the molar masses of each thing. It's right on the periodic table. You don't have to tell me which one is the smallest and what you're dividing by, because it's right there. Divide by smallest, I can look. Okay, I would like you to try one of these on your own. I'll show you the answer in a couple of seconds, but then just to make sure that you can do this. So please pause the video, work this example out. You may or may not need step 4. We'll let you figure that out. Okay? Please, if you have done this, if you have not, I really encourage you to do so, but your table, I've got some of the pieces left out, but if you compare the table with the answers that I've given you here, then your simplest formula ends up being that. Okay, now in this case, you would not have needed step number 4. Okay, trying a few more to find the simplest formula of each one. These ones I will not give you the answer for, but we'll talk about them later another time. Okay, molecular formula, the actual chemical formula. Now we already know that molecular formula and chemical and the simplest formula are going to be related. We need to get that extra step. So if I have a simplest formula, I can have these possible actual formulas, and all of these things on the molecular formula side are real compounds. They actually exist. I want to point out 2 things. Number 1 is that mathematically I might not be like actually multiplying the simplest formula by 2. Like I might not be able to take 2 of these CH units and actually put them together, CH2 rather, units and actually put them together, but mathematically that's what's actually happening. 2 things. Number 1, if I've got double the number of atoms, I've got double the amount of mass. That part is incredibly important moving forward, and you'll see what I mean in a few minutes. But I do want to treat the simplest formula as kind of a building block. And I have an example. You don't need to write this one down. This is just sort of like an idea of how we actually already know how this works. And we're not going to be dealing with bags of blocks. But if I think of the simplest formula as a building block, that I get several of them together, well, what does it mean? Well, if I had a bunch of blocks in a bag and they were identical blocks, I could easily figure out how many blocks I had by comparing the total mass, all the blocks together, with the individual mass of each building block. And if I do that, I figure out how many blocks I have. If I do exactly the same thought process for my molecular formula, which is made up of a bunch of simplest formula blocks, you can kind of see where this is going. So if I have a compound with a molar mass of, in this case, 98, and I've got all that represents all of the atoms or all of the building blocks, all of the simplest formula units, which are my building blocks, all of them together, and I know how heavy the individual block is, then I can figure out how many blocks I used, how many simplest formula blocks I used in making my molecular formula. What did I multiply the simplest formula by? And in this case, I end up with 7. So if I knew the simplest formula, I would have 7 of those. Okay, that's not the kind of question you're going to see, though. Getting a little bit closer, if I had a simplest formula, which we know how to do, then, and I told you what was the molar mass of the full thing. Now, if you were to look at that, 1 carbon, 2 hydrogens, 1 oxygen, nowhere near 240 grams. You can check, but you're going to need to know it anyway. You're going to need to figure it out. So if I look at the molar mass of the simplest formula, the building block, if I look at that molar mass, 1 carbon, 2 hydrogens, 1 oxygen, I end up with a molar mass of about 30 grams per mole. Nowhere close to 240, but I'm going to take a bunch of those and put them together to make my actual chemical formula. How many do I use? Well, a bag full. Well, no, but I take my total mass, 240, divided by the mass of the individual blocks, and I find out that I've got 8 building blocks, 8 simplest formula units in there. So now I can take my simplest formula, the building block, times 8, and I know that my total molecular formula is what we have there. Okay, let's add one more piece to it, because you're not often going to be given the simplest formula. We already know how to calculate the simplest formula. So now we look at this. And again, I really recommend you kind of work this through with me, and then we'll try a couple on our own. So we already know how to do this. So this is the completed table. If you're a little bit iffy on the simplest formula steps, please go through this on your own, because just writing these numbers down does not help you. But now I have a simplest formula, and I can use that simplest formula to come up with a mass of that building block, that simplest formula. Now I take my total mass, all the blocks combined, divided by the mass of each block, and I can figure out how many units, simplest formula units, I have in my molecular formula, at which point I've got 3. So now it takes 3 of those simplest formula units, and I have a molecular formula of that. Okay, C12H12O3. Okay, here's one for you to try, and again, I really strongly encourage you to do so because watching it doesn't help. Doing it helps. Right? By the time we're done this, we will most often have that full-on molecular formula question. Sometimes simplest formula is going to be enough. Usually we need to do the extra step. Later on in the course, I will not give you the molecular, the molar mass. I will not give you the mass of the whole thing, but we'll have ways to figure out how the molar mass of that. But that's much later in the course. And we'll talk to you later.